So good evening to all. Is the AV clear? Thank you. So before going to start our session, so I just want to have a small interaction with you. So let me know, are you feeling any difficulty in getting the ideology with regard to the concepts of real analysis? Anyone? So I just want to give one strategy for that. Since if you are attempting paper 2, usually people feel difficulty with the concepts like abstract algebra, real analysis, and fluid mechanics. The rest of the part in their course of study, they can have a look at least once. That is my opinion. Am I correct? In their course of study with regard to the academic background, whether it is BTech or something else. So these things, they won't come across in their course of study. Say, occasionally, some of the people have a small touch with regard to the real analysis, and some may have the touch with fluid mechanics. But this thing is totally different unless you have a BSc background or MSc background. So what happens, as per the examination point of view concerned, since you are learning for the first time, in order to get master over these concepts, it's take a time. So our intention is not to get the complete ideology over the chapter. Our ideology is mainly concerned with attempting the question in a successful manner. So that whatever the marks awarded for the question, we should be able to answer that question completely. That is my whole idea in general, as per the exam point of view is concerned. So what happens, even though if you take real analysis, we can bifurcate the whole real analysis syllabus into 5 to 6 main parts, just like sequences, series, continuity, differentiability, Riemann integration, and you can say improper integrals, and you can take one more, say uniform convergence. So in a nutshell, the whole syllabus is nothing but simply 7 topics, among which if you take the weightage or the questions asked, obviously you can have a compulsory question from the series part. The minimum weightage will be 15. Either you can take the compulsory section or the regular section. Here you can get a part here and here. The rest of the things will be taken occasionally while shuffling with the questions. So in the total 7 topics, if you are able to concentrate on 4, so that you are able to answer the minimum 30 marks from the real analysis part. Even though the examination weightage would be 50 marks, you should be able to answer at least 30 after learning these 4 topics with a broader perspective. So what happens, if you want to get a good mark and to get qualified in the final, what will be the score from paper 2 we should obtain out of 250? More than 150 or around 180? Say, are you getting me? If the score is 250, the total marks, if it is around 180 or 190, so are we able to get a good recommendation for the mains optional? So what happens, for every student, there are some particular topics which are favorite and which are non-favorite. So however, they become favorite for you because you have a prior course of study over them, or you have the subjective perspective and you have good knowledge with regard to those concepts. And which are non-favorite, you can have the choice that you are learning for the first time, or the logic behind it is somewhat difficult, or if you take the exam point of view, the difficulty level is more, etc., etc. So for those topics, what we are doing, we are concentrating on the questions from which portions they will come in majority, so that we are concentrating on those areas. If we are able to attempt a question, that is enough, so that we will get our required mark. So we'll have a good choice at the end to be qualified in the mains, isn't it? So for everyone, I am going to give one small session that you learn real analysis and you know all these methodologies. Later, you try to attempt all the previous year questions and majority of them I will cover in the class session itself. So if you have a confidence that we are going to attempt the questions taken from the favorite areas, then you are done. Because if you take the concentration especially only on real analysis, it will take a lot of time. And for abstract algebra too. So here, if you go with abstract algebra, it is purely theoretical or logical, not like problem solving orientation. And one interesting area is you can have the repetition of questions here. Why? Because majority of them are theorems. So the advantage of abstract algebra is you have the repetition of questions and there are some fixed models. And difficulty is it is purely theoretical and it takes a lot of time to cover the whole syllabus and much preparation is needed and you are learning for the first time. So these are the demerits with abstract algebra. And for real analysis, everyone will have their own demerits and merits. Am I correct? So keeping view of these things, so you give your suggestion so that how our class sessions would be more beneficial to us and to you. So the methodology what we are following here, is it comfortable for you? So if anyone is feeling difficulty, so you please inform so that we can do better. Any other comments or any feedback from anybody, please? And I feel that some of the students will feel scary if they are having and learning for the first time real analysis, right? So let us start our class session. So 1 by n square into log n, please solve it. The problem, yeah. Yes, the whole topic will be in this model only. So if you are saying that the few classes what you have done with regard to real analysis, if they are interesting for you, the remaining sessions will be in the same pattern only. If we are shifting from one topic to other, it will be totally different and it will be interesting. And there is no interconnectivity between this and this. Every time you are learning new methodologies while moving from series to continuity, differentiability, etc., etc. Every time you are learning different approaches. Fine. Okay. So if you say that summation 1 by n square log n. So can we say that if you take Vn is equal to 1 by n square, Un by Vn is equal to limit 1 by log n, say, is that acceptable? Yes or no? So here you are going to get the limit as 0. Then what happens? If you go for limit comparison test, you can say that if the limit value is becoming 0, if denominator is convergent, then numerator is convergent. So the denominator part is Vn. Since we know that sigma 1 by n square is convergent, so that given series is also convergent by limit comparison test. Fine. And we have similar models for these questions also. We can have an exercise at the end. So before going to start, I just want to take the previous problem of the last class one more time. Can I? Yeah. So there you have taken the problem that 1 plus 2 square by 3 square plus 2 square into 4 square by 3 square into 5 square plus 2 square, 4 square, 6 square divided by 3 square, 5 square, 7 square plus so on. So I just want to take the summary of the problem one more time. So there you have written the nth theorem Un. It is 2 square, 4 square, 6 square, so on, 2n whole square. In denominator you have 3 square, 5 square, 7 square, so on, 2n plus 1 whole square. And you have written Un plus 1 also. And we calculated the ratio Un by Un plus 1. And our thing is the given series is nothing but 1 plus sigma Un, excluding the first term. So after calculating Un by Un plus 1, you have the value like 2n plus 3 whole square by 2n plus 2 whole square. And if you apply the limit, it is going to be 1. So ratio test fails here. And here, apart from applying Rabi's test, we are applying Gauss test here. And we have given the condition of Gauss test already. Everyone is known with this. The thing is very simple. You should be able to expand the value of Un by Un plus 1 in the binomial form. That is the one main objective. So if you consider Un by Un plus 1, so by taking 2n common here, it will be 1 plus 3 by 2n whole square, and denominator you have 1 plus 1 by n whole square. So what happens? This equals to 1 plus 3 by 2n whole square plus 1 plus 1 by n whole power minus 2. Am I correct? As per the previous problem taken. Yeah, it is dot, sorry. Take it as star, right? Yeah. So I think up to this you have noted the problem, right? Yeah. Now, it is just like a plus b whole square. So 1 plus 9 by 4n square plus 2ab 3 by n. and it is of the form 1 plus x whole power minus 2. So if you expand 1 minus 2x plus 3x square and so on, and you are writing the terms after multiplying with this. So let us multiply all these values with 1. So it will be 1 plus 3 by n plus 9 by 4 n square. Then I am multiplying all the three values with minus 2 by n. So minus 2 by n minus 18 by 4 n cube, and then minus 6 by n square. And again you can multiply with plus 3 by n square with all these terms. So I can take so on, excluding that part. So this equals to 1 plus, taking LCM for these two, it will be 1 by n, and then taking the values of n square here. So 1 by n square, you will have a coefficient and other values. And what actually Gauss test says, if you are able to expand un by un plus 1 under binomial form, so you are able to write it as or represent it as 1 plus some number into 1 by n plus some value into 1 by n square, or terms involving 1 by n square, etc. So this number we are calling it as rho, the coefficient of 1 by n, and depending upon the coefficient of 1 by n, you are saying that if the rho value is greater than 1, it is convergent, otherwise it is divergent, isn't it? Could you check on the condition, please? So that is all about Gauss tests. So in a simple manner, what you are doing, you are simply checking the coefficient of 1 by n on multiplying the terms here. So if the coefficient of 1 by n is greater than 1, it is convergent, otherwise it is divergent. That is the only case. Clear? So do you have any questions for Gauss test? Right? So I just want to give an importance why Gauss test is needed. So in the previous class, we have done one more problem. So can I erase this if you have noted? Yes, area should be bounded also. Here you are going to get a sequence here now. Obviously it is bounded because you are doing under the binomial form. So obviously it is bounded. That condition will hold by default. So we neglect this criteria, only we concentrate on this thing, whether you are able to get a coefficient of 1 by n here or not. Right. So can I erase this? Okay. I think earlier we have done a problem that 1 power p plus 1 by 2 whole power p plus 1 into 3 by 2 into 4 whole power p and plus 1 into 3 into 5 by 2 into 4 into 6 whole power p and so on. So can you go through the problem once? So there what you have done, first you have applied ratio test, then since the power p is involved there, so apart from applying Rabi's test, you have applied the logarithm test. Then you have applied the second logarithm test also there. Can you check on that approach, what we did, everyone? So I just want to give the importance of Gauss test for this kind of problem, that so if you write the nth term, un is equal to 1 into 3 into 5 so on 2n minus 1 whole power p by 2 into 4 into 6 into 2n whole power p, and un plus 1 equals to so if you calculate un by un plus 1, after cancelling the common term, you are going to get it as 2n plus 2 by 2n plus 1 whole power p. Accepted? So apart from calculating the Rabi's test, log test, second log test, etc., are we able to apply the Gauss test here or not? We should have a question here. So if we say that if I am going to apply Gauss test, I must be able to expand this by means of binomial theorem, isn't it? Right. So how can I going to expand by means of binomial theorem? So by taking 2n common here, I can take it as 1 plus 1 by n whole power p. By here again taking 2n common here, 1 plus 2n whole power p. So I am going to write it as 1 plus 1 by n whole power p into 1 plus 1 by 2n whole power minus p. Accepted? Any questions, please? Right. So let us apply the binomial form there. So 1 plus 1 by n whole power p, if we apply in the binomial form, it is going to take it as 1 plus p by n plus p into p minus 1 by 2 factorial into 1 by n square plus so on. Just like PC0, PC1, PC2 and so on. So if you take the minus p value, the coefficients will be in terms of plus 1 will come. So I say that you are going to get it as 1 minus p by 2n plus p into p plus 1 by 2 factorial 1 by 4n square and so on. Accepts all? Right. So if you write the form of Gauss test here, it will come as 1 plus, here it is p by n, here it is p by 2n. Taking the values as common, you are going to get it as 1 plus p by 2n and terms involving n square, etc. So here O of n square means that terms involving n square and higher order. All of you agree with this expression or not? Say. Are you getting it? Fine. Any questions? Okay. So if you observe the coefficient of 1 by n here, it is p by 2. So from Gauss test, here we conclude that if p by 2 is greater than 1, it is convergent. If p by 2 is less than or equal to 1, it is divergent. In other words, if p is greater than 2, it is convergent, and p less than or equal to, it is divergent. So the same conclusion you have arrived by applying the log test as well as second log test. Could you check on that problem? So why I am taking this concept again means I have given a hierarchy of strategy already. So always we follow the strategy, no deviation at all. So sometimes what happens, apart from applying these tests in a hierarchy manner, straight away you can go with the advanced test if you know it. Because the condition of Gauss test is nothing but you should be able to expand by means of a binomial theorem, the ratio un by un plus 1. If you are able to do that, then there is no need of going with any other tests. That's all. Clear? So always we agree with the hierarchy pattern. We always go in that manner only. So sometimes you can apply Gauss test. So one checking criteria for Gauss test is if the value un is free of the terms x. If x is involved, we should follow the hierarchy: ratio test, Rabi's test, or ratio test, log test, next log test, etc. If it is free of x, then we can apply Gauss test straight away. That's it. So if it is clear for everyone, I am going to take the other test for you. I think it will be interesting for you, this test. So after noting, please inform. So can I erase? Okay. So the next one is Cauchy's integral test. Please take a note of it. I will dictate the statement, so please take a note of it. Yeah. Shall I? If u of x is non-negative decreasing integrable function, u of x is non-negative decreasing integrable function such that u of n is equal to un. U of n equals to un for all n belongs to z plus. For all n belongs to z plus, then summation n is equal to 1 to infinity un is convergent if and only if integral 1 to infinity u of x dx is convergent. So please take a note of it. Cauchy's integral test. So what is the outline of this test? It is very simple that apart from checking the convergence of the whole series, since you know that integration is nothing but summation, so the term un, we are treating it as a function here. So apart from verifying all the tests, you are simply calculating the value of this integral. If the integral value is finite, means it is convergent, so that infinite series integration both are equivalent. So integral is finite means this infinite series is also finite, so it is convergent. Okay. So apart from doing the infinite series checking, we are doing the integration, the regular integration what we will do. Fine. Are you getting the concept? Right. So let us take some problems on it. The first one is summation n is equal to 1 to infinity 1 by n square plus 1. So please don't misunderstand that if I am applying Cauchy's integral test here means other tests are not applicable here. Don't think like that. Other tests are also applicable here. We are simply learning different methodologies, among which whenever a particular question is given to you, you are able to pick up a suitable approach within the short span of time, and you are going to decide the nature of convergence. That's it. That is all you are doing. So here, if you observe un, it is equal to 1 by n square plus 1. So can you say that it is a decreasing function or not? If you say u of x is equal to 1 by x square plus 1, it is a decreasing function, isn't it? Yes or no? Because 1 by something, you are going to get the values are decreasing as and when x increases. And it is non-negative. It is giving only positive values because n is positive, x is also positive here. You are not taking the negative real numbers here. So we calculate integral 1 to infinity 1 by 1 plus x square dx. So how to calculate this type of integral? Apart from taking infinity sign, we write that limit say t tends to infinity integral 1 to t 1 by 1 plus x square dx. So do you know this technique? Yes or no? Integral 1 to infinity is just like limit t tends to infinity integral 1 to t. So we simply calculate the value. Limit t tends to infinity, it is tan inverse x between the limits 1 to t equals to limit t tends to infinity tan inverse t minus tan inverse 1 So what could be the value there? If you apply the limit, pi by 2 minus pi by 4. Accepted? So is that a finite value or not? It is a finite value. So since the integration is giving a finite value, so it is convergent. Therefore, given series is also convergent. This is Cauchy's integral test. So how to represent this on paper? First we write that un is equal to 1 by n square plus 1. Take u of x equal to 1 by x square plus 1. It is a non-negative decreasing function. Now we apply Cauchy's integral test. Consider the integral, evaluate the value. Since it is finite, therefore by Cauchy's integral test, the integral as well as series both are convergent. Therefore the given series is convergent. That is the writing notation on paper. Fine. So please take a note of it. We go for the other problems on this model. Now, can I say that, can we apply any other test here for this? If you don't know about Cauchy's integral test, what is the test I am going to apply here? Can I apply limit comparison test here? Because in the denominator, if you take n square as common, you can write it as 1 by n square into 1 plus 1 by n square. So you take Vn is equal to 1 by n square. So if you take u1 by Vn, it is just like 1 by 1 plus 1 by n square. And if you apply the limit u1 by Vn is equal to 1, which is not equal to 0. Accepted? So by limit comparison test, both converge or diverge together. So sigma Vn is equal to 1 by n square, which is convergent, hence it is convergent. Now see the difference. In this chapter, we are learning different methodologies. It doesn't mean that other methodology won't work here. We can apply the methodology also. We are just finally checking whether it is convergent or not. If one method fails, we are making use of the other method. That's it. Fine. So let us take one more problem. The problem is summation n is equal to 1 to infinity 1 by n into n plus 1. No, not at all. The best advantage of infinite series is every question will be given like this. Test the convergence of. That's all. So whatever the series is there, you take. Whatever the method strikes into your mind, you apply and to test the nature. That's it. That is the main comfortableness in real analysis. I think at this point you can like real analysis, the approach, because they won't ask any specific method. It is up to you what method you are using. So let us do this problem again. So here un is equal to 1 by n into n plus 1. Fine. So if I write the function form, u of x is equal to 1 by x into x plus 1. So I can say that by taking partial fractions, I can write like this. Why I am taking the partial fractions? Because I just want to compute the integral. I should know the integration. Because the statement is given that non-negative decreasing integrable function. So the function must be integrable here. So you calculate integral 1 to t u of x dx. Later we apply the limit. So integral 1 to t 1 by x dx minus integral 1 to t 1 by x plus 1 dx. So the value is log x between the limits 1 to t minus log of x plus 1 between the limits 1 to t. So if you apply the limits, so you are going to get it as log t minus log of t plus 1 is equals to log of t by t plus 1. The other limit gets cancelled. Am I correct? And if you apply the lower limit there, you are going to get it as log 1 by 2, log 2. Let us make one more point here. So if you apply the limits here, it will be log t minus log 1 minus of log of t plus 1 minus log 2. So log t minus log of t plus 1 plus log 2. Am I correct? Yeah. So if I apply limit t tends to infinity, so integral 1 to infinity u of x dx is equal to limit t tends to infinity integral 1 to t u of x dx. So this equals to limit t tends to infinity log of t by t plus 1, and this will be log 2. So limit t tends to infinity log of 1 plus 1 by t plus log 2. The value will be log 2 here. So which is a finite value? Please check. If anywhere I go wrong, you please correct me. Yes, that is also right. But the thing here is we have one more chapter left where we go for improper integrals. There what we will do, whenever the indefinite integral is there, the improper integral, so there we do, apart from applying infinity straight away, we do like this. So that is a structural thing which we learn at improper integrals chapter. Let's say we are following the same criteria. However, in the calculus, we apply infinity straight away. But here is the different issue. Fine. So since log 2 is a finite value, the integral is convergent. Hence, the given series is also convergent. Please understand that I can say for this problem also, we are able to apply the limit comparison test. You can check on that. By taking Vn is equal to 1 by n square, you are going to apply the limit comparison test there. That is possible. So there are different approaches. We are taking one of them. So you please take a note of this. I'm going to take one interesting problem which is given in the previous year paper. So this problem we are going to do it with Cauchy's integral test. After noting, you please tell. So all of you noted? Fine. So here the question is, show that summation n is equal to 1 to infinity 1 by n power p, p greater than 0, is convergent if p is greater than 1, divergent if p less than or equal to 1. I think this problem is given in the previous year papers once. You please take a note of it. So since p is greater than 0, so we are going to apply the Cauchy's integral test here in 3 cases. So we take p is equal to 1, and we take p is greater than 1, and we take p is less than 1. So these 3 cases we are going to consider here. And in each case, by taking the use of Cauchy's integral test, we are going to decide its nature, whether it is convergent or divergent. That is the whole idea. Fine. Okay. So first of all, I am going to take the case that p is equal to 1. So since we take that un is equal to 1 by n power p, this is equal to 1 by n. Now we take u of x is equal to 1 by x. So you calculate integral 1 to infinity u of x dx is equals to limit t tends to infinity integral 1 to t 1 by x dx. So equals to limit t tends to infinity log x between the limits 1 to t. So equals to limit t tends to infinity log t minus log 1. So obviously its value will be log infinity equals to infinity. Right. Is that okay? So even though we know that it is infinite value, we should represent it in the prescribed manner as per the problem is considered. Okay. We cannot say straight away that log x takes the infinite value. It is not a bounded function. We cannot say like that straight away. We should do the traditional procedure as it is. Since the value is not finite, therefore, for P is equal to 1, given series is convergent by Cauchy's integral test. So at this point, what we do? By Cauchy's integral test, given series is divergent. So I say that every person should ask one question, that if you take P is equal to 1, Un is equal to 1 by n. So summation Un is nothing but summation 1 by n. As per P series test, straight away it is divergent. We know this, right? We have done P series test. So immediately you should ask, so can we do like that? But actually, here we are proving the P series test here. Please understand. It is nothing but P series test. So unless you prove, you cannot apply the test, right? So Cauchy's integral test is a technique for P series test condition. This is the condition of P series test we have noted earlier. Yes or no? So how the condition came? By using Cauchy's integral test. I think it makes sense. So you cannot apply the thing here straight away. Is this clear? Then I go with the other part. I am going to erase. May I? Okay. So you take the case that P is greater than 1. So we can say that P minus 1 is greater than 0. And we are going to apply the same condition. U of n is equal to 1 by n power p. So u of x is equal to 1 by x power p. This is the value. Now let us do the integration. So if you apply the integration part here, integral 1 to t u of x dx you consider is equal to integral 1 to t 1 by x power p dx. So it is just like integral 1 to t x power minus p dx. So x power minus p plus 1 by minus p plus 1 between the limits 1 to t. So equals to 1 by 1 minus p into x power minus t plus 1 minus 1. Am I correct in getting the thing? Right. So you can do a little modification here. You can take it as 1 by p minus 1. Why? Because p minus 1 is greater than 0. I think I have done a little mistake there. You are applying 1 power something, right? 1 power something is nothing but 1. Right. Yes, t should be in place of x. Yes, that's what I'm saying. Yeah. So it will be t power minus p plus 1 and yeah, it is correct right now. Fine. So 1 by p minus 1 into, you can take it as 1 minus 1 by t power p minus 1. So I'm going to write like this. Accepted all? So to this part I am applying the limit. So what will be this value here? So 1 by p minus 1 into 1. So it will be 1 by p minus 1, a finite value. Since it is a finite value, the given integral is convergent, hence the given series is convergent. So when p is greater than 1, 1 by n power p is convergent. Okay? You please take a note of it. Then we go for the other case which is there. Any questions? Is that okay? Fine. So let us take the other case that we have to go with p greater than 1, p is equal to 1 and p less than 1. We have done with this case, and with this case we have to take like this. Since p is greater than 0, if you take the case of p less than 1, the possibility for p is 0 less than p less than 1. So you are considering the case that 0 is less than, p is less than 1. That we are taking actually. So let us do the same procedure as usual. So I will erase this. We take that 0 is less than, p is less than 1. This is u of n, this is u of x. So 1 to t u of x dx, 1 to t 1 by x power p dx. Same integration will come. So this is the part we take. So therefore, limit t tends to infinity, integral 1 to t u of x dx, if you consider, this is equal to 1 by 1 minus p. And what will be this bracketed expression here? Is it finite or infinite? Because 1 minus p is positive. So you were saying that it will be an infinite value. Can you check on that? So since the value is not finite, the given integral is divergent, so that the given series is also divergent. So if you want to write the proof of p series test, this is the proof. And this proof is asked once in the exams. So apart from asking prove p series test, he will give the statement of the condition like this. So can I go for one more thing on this Cauchy's integral test? I think This is also one of the previous year questions. Can I erase this part? Okay. The question is that summation n is equal to 2 to infinity 1 by n log n whole power p is convergent if p greater than 1, divergent if 0 less than p less than or equal to 1. This is the next problem. So please take a note of it. It is also one of the previous year questions. And obviously the function n log n is a non-negative function and which is a decreasing function. And it is integrable. 1 by x log x, is that integrable or not? It is integrable. Now we can apply the Cauchy's integral test here. Here also it is the same procedure for the previous problem, just like that. So we have to consider the cases p is equal to 1, p is greater than 1 and p is less than 1. These three cases you are also considering for this problem. So let us take the case that p is equal to 1. So the function u of x is equal to 1 by x log x. Since p is equal to 1, so let us go for the integration part. Integral 1 to t u of x dx is equal to integral 1 to t 1 by x log x dx. Any idea for doing the integration part? How to do? And one modification here is, since the summation is varying from 2 to infinity, we should make use the thing that the integration is from 2 to t. Please take a note of it. Right, that's a good one. So let us log x equal to z. So 1 by x dx is equal to dz. Or you can take, okay, t is already used, so take z, right? So integral 2 to t 1 by z dz. So the value is log z. So 2 to t. This is equal to log of log x 2 to t. So this is equal to log t minus log 2. Accepted? The integration part. So if you apply limit t tends to infinity here, since it is a constant, we don't apply here. If you apply limit t tends to infinity, this part will be infinity. Because summation is varying from 2 to infinity. Because if you take n is equal to 1, it will be log 1, the value will be 0, it becomes undefined. Since the summation is varying from 2 to infinity, we are taking the integration from 2 to t. Yeah. Right. Is this part clear for everyone? Say. Fine. So let us go with the other case that suppose the case, so in the first case p is equal to 1, it is divergent, that we have proved. So take the case that p is greater than 1. So u of x equals to 1 by x into log x whole power p. So if you go for integration, limit 2 to t u of x dx equals to limit integration 2 to t, sorry, integral 2 to t u of x dx is equal to integral 2 to t 1 by x into log x whole power p dx, and we are going to do the integration here. So if you take same log x equal to z, 1 by x dx is equal to dz. So it is going to happen as integral 2 to t 1 by z power p dz, so equals to integral 2 to t z power minus p dz. So z power minus p plus 1 by minus p plus 1 between the limits 2 to t. Z is nothing but log x. So log x whole power 1 minus p by 1 minus p between the limits 2 to t equals to log t whole power 1 minus p minus log 2 whole power 1 minus p whole by 1 minus p. Please check. Yeah, the value is finite if you apply limit t tends to infinity. Accepted? You want that limit part also. Say. Yeah. So in the same way we can do that when p is less than 1, the integral will be divergent. You are going to get it as infinite value. So this kind of question is asked in the previous year papers. Yeah, I will apply the limit. Just hold on a second. I will make space here. Just since p is greater than 1, minus p is less than minus 1, 1 minus p is less than 0, therefore p minus 1 is greater than 0. So to have this, we can write that 1 by 1 minus p into 1 by log t whole power p minus 1. Then write 1 by log 2 whole power p minus 1. If take a common, 1 by p minus 1 into fine. Please check on that. How I have modified the part. So if I apply limit t tends to infinity, this will be 1 by p minus 1 into some finite value, and this will become 0. Okay? Right. So if you take the other case p less than 1, there is no need to go for modification here, since 1 minus p is positive. If you apply limit t tends to infinity, straight away it is infinite here. So there is no need to do modification at this part here, like this. The same fraction we consider, the value will be infinite. The same integration will take place. Okay, for the other case. Yeah. So any more questions with regard to the Cauchy's integral test to anyone? If not, I just want to take one small test. There I can sum up with the test conditions. We start a small topic with regard to infinite series. There we conclude the infinite series part. So I just want to take one more session tomorrow. There we can conclude about this whole infinite series chapter. So after noting this, you please inform. So the next one is nothing but Cauchy's condensation test. So earlier you have done with Cauchy's integral test. Now you are doing with Cauchy's condensation test. So I will give the statement. You please take a note of it. And I just want to take one problem on this because with regard to examination point of view, it has less importance. And in the previous year questions, we just have one problem on this model with regard to Cauchy's condensation test that I will cover in the class now. So please take a note of the statement. Shall I? Okay. If f of n is positive, monotonically decreasing function, positive, monotonically decreasing function for n belongs to Z plus, then the two infinite series summation f of n comma summation a power n into f of a power n, where a is greater than 1, a belongs to Z, both converge or diverge together. Both converge or diverge together. I repeat, if f of n is positive monotonically decreasing function for n belongs to Z plus, the two infinite series summation f of n, summation a power n into f of a power n, where a greater than 1, a belongs to Z, both converge or diverge together. Is the statement clear? All of you? Yeah. Sorry. I just want to give the whole idea that suppose this is my given series. I just want to know the nature of convergence for this series. But actually what happens, I feel a sort of difficulty in getting its nature. So apart from calculating the nature and the test conditions for the given series, I consider this series. So with the known tests which are available to me, like ratio test, Rabi's test, limit comparison test, whatever the test it is, I am applying the test condition for this new series. If the new series is convergent, this is also convergent because both are equivalent in nature. That is Cauchy's condensation test statement. So apart from taking the given series straight away, I am taking the another series. I am applying the test conditions on that new series. Okay? Is that fine to all? Right. So let us take one problem. That is one problem is enough for this thing. It is just for an idea, not of much importance. The problem is given by log 3 whole square by 3 square. This is the problem given. The given series is this. So if you write the nth term, it will be log n whole square by n square. Accepted? This is our f of n. So now what I am doing, I am not taking this series, I am taking the other series. So I am taking, consider a power n into f of a power n. So how I am going to write it as? It is nothing but in place of n, you write a power n. N starts from here 2 because this is 2, right? That's why n starts from 2. You just need to understand one thing, that summation n is equal to 1 to infinity, summation n is equal to 2 to infinity. In one way they are equivalent. It is nothing but you are taking infinite term sum, you are taking infinite term sum here. So if you have a little doubt, you can write it as log 1 whole square by 1 square, because it is already 0, it has no effect. If you have a traditional form like summation n is equal to 1 to infinity, this series I just want to take, so you can write like this. It won't affect the given series. Agreed? So even it is n is taking from 2 to something, by adding one more term, it won't affect the given series. So if you are very particular, the index of the summation, in exam we can write that we add the term log 1 whole square by 1 square, so that summation n is equal to 1 to infinity f of n is equal to summation n is equal to 1 to infinity log n whole square by n square. Clear? That's it. Yeah. So we are writing a power n into f of a power n, it is equals to a power n to, in place n, I am writing a power n. So log a power n whole square by a power n whole square equals to 1. A power n gets cancelled here. Here you can write it as n log a whole square by a power n. Again, if you want to go for a modification here, it is equals to n square log a whole square by a power n. Okay? That also we can do. So if you are particular about n is equal to 2, then we can write it as log of n plus 1 whole square by n plus 1 whole square. That is also correct. We just want a form, that's it. Because if you write f of n is equal to log of n plus 1 whole square by n plus 1 whole square, you are correct. For n is equal to 1, this will come, n is equal to 2, this will come, and so on. Accepted now? But what happens if you write a power n into f of a power n, it becomes a little tricky here, how to simplify. That's why I simply write, if I add one more term, it won't affect the convergence. To have the computational convenience, I have written like that. Now, this is my term, a power n into f of a power n is equal to n square into log a whole square by a power n. All of you agree? Any questions, please, so far considered? Yes or no? So here, a is any number which is greater than 1. Right? A is any number which is greater than 1. So let us do that. Now what happens? You are going to decide the nature of this series here. Please understand. You should say a power n into f of a power n is convergent or divergent particularly. You should give the condition over this. How I am going to do? For convenience, I am taking it as un. So by default, the most comfortable test is nothing but ratio test. So I will take un plus 1. This is equal to n plus 1 whole square into log a whole square by a power n plus 1. So if I calculate un by un plus 1 and its limit, So un by un plus 1 you consider. Let us write the values. N square into log a whole square by a power n into a power n into a by n plus 1 whole square into log a whole square. So log a whole square gets cancelled, a power n gets cancelled. So this is equal to a into n square by, so n square into 1 plus 1 by n whole square, n square gets cancelled, so a into 1 plus 1 by n whole square. So please check on that in the simplification part. So if I apply limit here, limit n tends to infinity, un by un plus 1. So for this, the limit is nothing but a. Since we know that a is any positive integer which is greater than 1, therefore the limit value is greater than 1. Hence by ratio test, it is convergent. So which one is convergent? The newly obtained series, this is convergent. Therefore, by Cauchy's condensation test, the given series is convergent. Is it fine now? The approach? So in a nutshell, what we did, just recollect. Whatever the series is there, you have written that as f of n. That is step 1. What is step 2? In place of n, you write a power n, and the new series we are calling it as a power n into f of a power n. You have obtained the series there. On simplification, the nth term of the series is there. Now you are checking you are applying the limit comparison test, ratio test, all these things on this new term which you have obtained there. So if this is convergent by means of the test which you got, then by Cauchy's condensation test, this is convergent. Okay? Is that scenario clear? Any more questions, please? Yes or no? Fine. So let us wind up our session here. Let us have one more approach. The test with regard to infinite series complete here. We are left with one small topic that is called alternating series, which we are going to discuss in the next session and which is very important with regard to examination point of view. So alternating series. I just give the definition in this class. Root of n plus 1 minus root n is divergent. You are asking that? The question? Yes, it is divergent. Because if this is the problem taken by you, say we go for the rationalization. So this will be 1 in the numerator. So root of n plus 1 plus root n. So if you take root n as common here, so root of 1 plus 1 by n plus 1. So Vn is equal to 1 by root n you take. By limit comparison test, it will get. Yes, in Raisinghania book, you get that it is convergent. The answer is mistaken there. I agree with you. So please understand all of you that everyone is well versed with the methodologies in the class. We will have a discussion and everyone is according to their own preparation will follow a standard test book. Always standard textbook is 99.99% correct. But you cannot say that it is 100% correct. There are some mistakes. Please understand, all of it is nothing but a book printed there. So if your book contains 600 pages, the proofreader cannot check each and every point of it. Even though proofreading is there, some errors will occur. So the best thing is, as and when you got it out, we can have a discussion in the class, or we can have the posters in the group. We have the Telegram group, right? So you just give the posters in the group, so everyone will have a discussion on it, then they will consider. Okay? That was one good solution. Because always we go with the majority rather than the minority to have the truth. So do you agree with this or not? The rationalization part. Fine. Yeah, I stuck with giving one small definition, that is alternating series. I just take one definition. The thing is, this is a series, right? Now alternating means we just write the symbols alternatively, plus minus, plus minus, plus minus, so on. So a series in which the symbols are alternative is called alternating series. And we are defining whether it is convergent or divergent by means of a test. That's all. That is the concept of alternating series, which we discuss in next class. Is it okay? So let us wind up our session here. So if you have any other feedback, you can give. Any comments, please? Yes or no? How yes are there for it? I didn't get you actually. How yes are there for it? Can you elaborate? Yeah, very simple, just one test. Yes, for alternative series, there is only one test that we discuss. So again, in alternating series, the previous 4 tests like ratio, limit comparison, etc. will come again. So there is no need of logarithmic, Bertrand's, Gauss, Cauchy's integral, etc., etc. We don't need them. We just take the previous 3 to 4 tests. That's all. Trigonometric functions converge test. You are asking about the Dirichlet test, Abel's test, etc. That will come in a separate case. While discussing with uniform convergence, you will get. So trigonometric functions convergence also taken by these things, the alternating series. Tan inverse. So that thing usually won't come, that type of thing. At the most, you take the regular trigonometric like sine, cos, not inverse functions. Okay. Any more queries, please, to anyone? If not, let us wind up our session here. Yes, in exam, there is no question from the inverse functions with regard to infinite series. Yeah. So thanks to all. Good night.